I just want to kind of start off here with how we take keyboard input. So this example is actually from our game engine, but the same concept applies. When we do something like hit a left arrow key, if we're holding it down, we know that in our iteration of the game loop, if there's something pressed like a left arrow, we're going to like move a character, or we're going to do something because we know the state. So outside of the game loop, we have events happening, events firing, such as key presses. So we're going to save that state, or if there's multiple key presses. All of that sort of thing we want to abstract. So keyboard's pretty simple, and I'm just going to move on from keyboard. Mouse is simple as well, but it's a little more involved now that we have touch devices, right? Everyone has at least a phone with a touch device, with a touch screen on it. And when you have touch devices, you could have multiple inputs, right? You could have multiple points. So the easiest thing to do is that if a game, you have a game that supports a mouse and you're moving things around on the screen, you could just grab the first point. And again, we sort of abstract that in our game engine. We take the position in the mouse. If it's a touch device, we'll just take the first one and, like I said, emulate that to a mouse. So you only have to worry about mouse, and that's fine. However, there's a lot more things you can do than just moving a single finger on screen. So we want to handle that. So one of the things that we did with the game engine was we incorporated a library recently called Hammer JS, which is really cool because it does a lot of the stuff that we didn't want to do. There's a lot of math involved in things like pinch zoom and swiping and all these gestures. But again, these gestures don't happen the same timing as our game loop. So what we want to do is listen for a gesture such as swipe, and then put that somewhere that our game loop is going to pick up and maybe deal with and throw away or whatever. But that way we can abstract that. It's an A and B module. We pull it in, we build it into the game, and we're good. So just a real quick demo on how that works. When we have, here's a bunch of isometric zombies. If we're moving a mouse around, we're just holding something on the screen. Every iteration we can go towards a point. But if we want to do a gesture, such as a swipe, we want to do that once and throw the event away. And so this is all this is doing. It's just swiping and throwing the zombies around the screen. OK, so cool. Gestures. OK, well, that's so we got gestures, we got mouse, we got keyboard. That stuff's all cool. But gamepads, right? We want to play a game with a joystick or a gamepad. And this is still prefixed, but we can get from the navigator a list of gamepads. Now, these actually work really well within a game loop because we're not sending event data from the controller. We're just modifying. Well, the API is just modifying the state of the controller. So when it's plugged in and we grab the first one off of that stack for, say, player one, all of the buttons and things will, well, why don't I just show you? We'll just check the state. So I stole this one directly off of HTML5 rocks. Here's just a generic controller. And first demo fail. First demo fail. This works really well usually until you go in front of everybody and try to do it. Oh. Wrong. Sorry. OK. Imagine that there was a picture of a controller here on the screen. This isn't really all that big of a deal. But all we're doing is we're checking each button state from a 1 or a 0. If it's an analog joystick, we'll get a 0 to a 1, a floating point, or to a -1, depending on the axis. So that's fine. That stuff's all cool. But I call this postmodern game input devices because all that stuff is sort of the current state, right? I mean, the Gamepad API is new, but that's what we're used to playing games with, is those sorts of things. So the first one I want to do, there's been a few of these demos come out lately, is using a phone as a gamepad, right? Go to iTunes or Google Play, grab an app. But there is an app for that, and it's just called a browser. Like, don't go and install anything. So let's see here. I got to time this just right, or or you guys can really screw me up because I'm showing a QR code. Okay. Also, there's a bit.ly link if you guys really want to mess with me while I'm doing a demo. So sort of what, if you guys were in Remy's talk earlier, he was taking orientation events from a device. In this case, this is pretty simple box 2D stuff. And all I'm doing is applying torque to the wheels based on the orientation that I'm headed in. Also, it's really easy to get the thing stuck, so why not just emit event, like a button to flip the vehicle over. Now, the reason I had a QR code and a bit.ly link was so that I can make sure to join the same WebSocket. The page goes to a WebSocket, just grab some random ID. The phone has to go to that same WebSocket so that we got controls. So okay, cool. We've got WebSockets, phone, controller. So we don't even need a gamepad. We just use our phone. Okay, thank you. But you have to use your hands. That's like a baby's toy, right? We don't want to use our hands for this. What do we want to do? We want to maybe use the camera to track our face. Now, I'm not going to demo this one, but this was actually pretty cool. This is, of course, if you're a unicorn, you're going to catch donuts. So a company called BeReal Software, they did a Google Hangout app where it's tracking your head and you catch donuts in a Hangout. So this isn't a W3C spec. It's just an API. I don't know the magic behind it, actually, but it's pretty straightforward. When you're creating a Google Hangout extension, we've got events that we can hook into. The track event that gets passed into this event here, or the track event object, has all the things that you'd expect, like your noses, X, Y, your eyes, some of that type of information, so that you can do all kinds of crazy stuff in a Hangout. So face tracking would be cool if that was just a spec and we could just use it for other things. But kind of a neat thing to play around if you're into doing Hangout apps. Okay, we want to talk to a browser by talking to a browser, right? Like, why wouldn't we just do voice rec? Why couldn't we just tell the game what we want to do? So we have something for that, and this is actually a spec, the web speech API. Of course, prefixed right now. All we have to do is create one of these web speech recognition objects, and we can do some events on that. Now, this demo is very dependent on how well the internet connection is working here. So let's see if I can do another demo fail here. Whoa. Up. Oh, allow, sorry. I allowed it on the last machine. Oh, by the way, just like with WebRTC, web speech, you have to run it on HTTPS or you're going to get that allow every time. And this is a little bit worse because, well, look at it, it's taking my voice here. Why don't I do the demo first? And then, okay, up, right, up. There we go. Okay, so it worked, sort of. Left. Left? Well, this isn't perfect, right? It's a neat concept. We can talk to the things. We have a few issues. One of them being that, like I said, it has to run on HTTPS. If it doesn't, we have to allow it every time. We have to hit allow every time we want to take speech input. Also, this is very network dependent because it's really just sending waveforms back up to Google servers where they're translating and sending events back. And there's a little bit of bugs in some of the way the events work. But theoretically, we should be able to do voice rec using a standard API to move things around on a screen. And okay, so cool. We have web speech. Okay, now these are more fun and probably more reliable. 3D tracking. So everybody see that new Xbox One thing? They're like, it's not a, I don't think it's a peripheral. I think it's part of it now. Microsoft has Kinect, which takes 3D data in. There's also Leap Motion, which is right here. Now, I really like Leap Motion. Leap Motion is cool. First of all, it's just this cool little device here. But what Leap Motion is doing right, and if there's any hardware manufacturers in the room or anybody working on a cool project, their driver is a WebSocket. So, well, their driver is a bunch of code, but they give you a WebSocket when you install their driver. And And command what? It's running? OK. Let's see if this is running. OK. The local host should have a WebSocket emitting data from this thing. So this actually takes in a bunch of image data, and the WebSocket's going to give us back just the things that we're interested. So let's see here. Let's look at the first one. So OK, cool. So it's working. All I'm doing here is taking X, Y, and Z data in the form of pointables. So what the local WebSocket gives us as soon as we connect to it, it starts streaming all this position information. It also gives us some things like the POM and the JavaScript library that there's a JavaScript library on GitHub that LeapMotion's putting out. Gives us a bunch of other things, some other events. We could smack down on it. I think it's a little bit more difficult to do like a wave thing because we have all the fingers stacked up and it's looking at them this way. But smacking down on it works. A bunch of other gestures. I mean, they encapsulate all that stuff pretty well for you. So we just have to make a connection to the Leap controller. And then every frame that the thing gives us, in this case, I'm putting it on the game. So we're keeping the state of those pointables. Now, this is also important when we consider that our game loop is going to run 60 times a second. This thing is capable of emitting data, I think, 120 frames a second. So we don't need all of those positions. And I'm pretty sure we can control how much data is coming off the thing. But what's important is that we just want to save the state at any given point when we render. So the demo, moving my hands around on it, I'm just saving the state of each pointable, 4 fingers in that case, and just drawing them in my draw loop in my game. OK. What would be slightly more useful is actually in a game if we were to do something. Now, this game in particular, it's a pretty simple game. Everybody's played Breakouts. What's cool about this particular Breakouts is, anybody do MVC? To do MVC is like well, I can't talk and do this at the same time. Yeah, I'm going to fail. To do MVC is really cool because it's a list of a bunch of different MVC implementations. So you can figure out which MVC or MV star or MV whatever API that you want to use. Wow, that thing's still going. Just die. OK, good. Breakouts is like the to-do MVC of HTML5 games. So check that out. Matt Greer's done a great job putting that together. Our open source engine is one of the ones on there. So if you want to get into it and just kind of see which game engine is for you, go check that out. OK. So let's see here. I'm running a little ahead. So cool, that's cool, right? But we all want to wear the things, and you guys probably know where this is headed next, right? We want to wear our computers. We want to have them right there in our eyes. So what are we going to use? Project Glass. Actually, this thing is, I know it's goofy, but this is really cool, some of the stuff that's happening in here. OK, not only, like, everything to me is the heads-up display, right? Awesome, having a heads-up display. But there's a bunch of really cool sensors in here. There's a wink sensor. There's a touchpad on here. So there's all kinds of stuff on here that I want to use and I want to, do game stuff with. And the default way of doing interaction with this guy is using what's called the Mirror API. Now, your Glass talks to Google servers, makes REST calls out to some other service. There's some OAuth involved. You can get a Twitter notification. All that stuff is cool. But it doesn't really help me to move characters around the screen so much, or to get characters from here, or do multiplayer up here, or any of that. So I want to do more real-time applications. So I put together something called Face, which is basically WebSockets using a Java library. One of the things that I like about what Chris and others are doing with Nodecopter and with Fermata is that I don't really want to write in C, I want to write in JavaScript. And if you have this firmware on an Arduino, you could connect a serial port and you could do stuff with that Arduino in JavaScript. Well, similarly, I don't know how many of you want to write in Android and in Java, but I'm trying to do some of that for you by just exposing a bunch of the stuff that's in Glass to a WebSocket. So I go to this application. There's a little launcher. Well, one other thing. there's a USB port on here. And you can put it in debug mode. So you could sideload Android 404 things. There's a couple of WebSocket implementations in Java. Pull those in, put up a heads-up display so we can kind of see what we're doing. And go to this application. I could send messages to it. APR stands for azimuth, which is orientation this way. Pitch is this way, and roll. And of course, error messages, a couple of buttons to do some navigation with. And that channel ID. You can imagine that channel ID is the WebSocket I want to connect to. Or I'm going to connect to a WebSocket. I'm going to say, go to this channel. And I'm putting it in my eye, so when I do this demo, you guys can't go to that one and screw me up, because I could see what the channel is in here. I didn't want to, for the type of applications I want to build, I didn't want to go to a third-party server. I just wanted to go to some node server. So Glass here is running this face application, talking to Node, doing WebSockets off to some other client or multiple clients or whatever you want to do. And since I have that running, I can see what the channel ID is in here. Let's see here. This is a really cool 3JS demo that I just took off the 3JS site. But I wanted to do a little bit of integration with data from the Glass. So, what's that? So that you guys don't put in the channel and screw up my demo. All right, so we've got some orientation events, right? Do we have orientation events? Yes, we have orientation events. OK. But like I said, I like putting these things together, right? I like that we have WebGL and we have WebSockets, and we got one of these. So why not put them together? Peacock. Peacock. Whoa, so loud, right? OK, so why not take the events onto, take our orientation events, do a little bit of WebSocket integration here, and expect that Bluetooth is going to transmit stuff back to the, anyways. So you get the concept. Connect all the things, WebSocket. Wow, that's weird. Anyways, are we dancing? There we go. All right, cool. All right. OK, enough of that. All right. I'm actually, that's really about all I have. I just want everybody to connect all the things, right? Connect all the things. WebSockets are your glue, right? All these devices, we plug them in, we talk to Node, we bounce stuff around, we do stupid disco demos with WebGL and 3JS, and that's it. Any questions?